Something brushes against your foot, a feather, a bug, a loose thread, and before you even look down, your whole body reacts. A jerk, maybe even a laugh, bursts out before you choose it. And then, almost as a reflex, you try it on yourself. You run your own finger along the same spot, expecting the same reaction. Nothing happens. Not a flicker, not a twitch. You can press just as hard, move just as fast, touch the exact same patch of skin. And somehow, it just lies there, doing nothing at all. Most people shrug this off as one of life's small, forgettable oddities. But it's not trivial. It's actually one of the clearest windows we have into how your brain decides what's real. Here's what's happening. When you move your hand, your brain doesn't just send the command and wait. It sends a second, quieter copy of that same signal to another part of your brain, your cerebellum, tucked at the base of your skull. That copy is a forecast. What's about to touch you, where it will land, and how strong it should feel. In 1998, researchers at University College London put this to the test. They put people in a brain scanner. First, the person touched their own palm. Then, someone else touched the same palm in the same way, with the same pressure. The physical stimulus was identical both times, but the brain's response wasn't. When the touch came from someone else, the somatosensory cortex, the part of your brain that processes touch, lit up far more strongly. When the touch was self-produced, that region stayed quieter. The cerebellum showed less activity too. Exactly what you would expect if the brain had already predicted the touch and turned the volume down before it landed. Your own touch isn't a surprise, and it turns out tickling only works when something is. So here's a question worth sitting with for a second. If your brain can predict its own actions that precisely, is there any way to fool it? Scientists tried. They built a small robotic arm controlled by one of your hands that would press a piece of foam against your other palm, but with a short, adjustable delay. When the delay was 0, the touch felt exactly like touching yourself. Barely anything. But as researchers stretched that gap out, even by a fraction of a second, the sensation started to change. By around 0.2 of a second, people rated the touch as noticeably more ticklish. The longer the delay between your action and the resulting sensation, the harder it became for your brain to link the two, and the more the touch started to feel like it came from somewhere else. In other words, you can trick your own nervous system. All it takes is breaking the timing your brain depends on to know what's yours. Which brings up something stranger. If this prediction system is just a matter of timing and wiring, what happens if that wiring doesn't work quite right? There's a small group of people who actually can tickle themselves. Not with a robot. Not with any trick at all. This showed up in studies of some people with schizophrenia, especially people with passivity experiences. The unsettling sense that your own thoughts or actions are being controlled by someone or something outside yourself. Patients experiencing this rated self-produced touch as much more similar to external touch than most people do. It looked as if their brains were not labeling their own movements as clearly as usual. A few years later, a separate study found something even more striking. You didn't need a diagnosis for this to show up. Even in healthy volunteers, people who scored higher on schizotypal traits, mild non-clinical measures linked to unusual perception and self-experience, were more likely to feel self-produced touch as ticklish. In the lab, that ability isn't treated like a party trick. It can be a clue that the brain's self-monitoring system, the one drawing the line between me and not me, is working a little differently than usual. For the rest of us, that line holds firm. Which raises the last and strangest question, why does ticklishness exist here in the first place? That question matters more than it sounds like it should. Tickling is a strange thing for a body to do. It makes you laugh, but it also makes you pull away. It feels playful, but only if the person doing it is safe. The exact same touch from the wrong person stops being funny immediately. So whatever ticklishness actually is, it sits right on the border between threat and trust. Nobody has settled which side it's really on. In 1924, a psychologist named J.C. Gregory noticed something that still gets repeated today. The most ticklish parts of your body are also the parts most exposed in a physical fight. Your neck, your ribs, under your arms. His theory was that ticklishness trains you, from childhood, to flinch and protect exactly those vulnerable spots, almost like a rehearsal for combat you'll hopefully never need. It's a tidy idea, except it runs into a problem almost immediately. The soles of your feet are among the most ticklish places on the body, and nobody's throat gets attacked through their feet. Researchers studying social touch point somewhere else entirely. Not danger, but bonding. Playful tickling between a parent and child or between siblings produces exactly the kind of shared laughter that strengthens a relationship. Under this idea, ticklishness isn't about defense at all. It's social glue. And if that sounds too modern, brain scanners, robots, clinical studies, the older clue comes from rats. In the early 2000s, researcher Jaak Panksepp started tickling rats, specifically at the back of their necks, and recording the sounds they made with equipment sensitive enough to pick up frequencies far above human hearing. What he found was a burst of high-pitched chirping, the kind researchers associate with playful, positive states in rats. In another branch of the mammal family, something that sounds an awful lot like laughter was already there, waiting for a light touch in the right spot. So depending on which researcher you ask, ticklishness is either an ancient alarm system for your softest, most exposed places, or an ancient invitation to bond, running on hardware old enough to predate humans entirely. Nobody has settled the argument. Both explanations are still standing over a century after the question was first seriously asked. What's not up for debate is the part happening inside your own skull, or right now, every single day. Somewhere in your cerebellum, a quiet, constant forecast is running, predicting your next move before you finish making it, so precisely that it can cancel out the exact sensation you're about to create. It's not something you asked for. It's not something you can switch off. Try it anyway. Run a finger along your own arm, slow and light, exactly like you would to someone else. Your brain will know before your finger gets there. It always does. There's one more piece of this that's worth sitting with, because almost everyone has noticed it without ever asking why. Some people are far more ticklish than others. A light touch that makes one person collapse into helpless laughter barely registers for someone else. Part of the answer is simple anatomy. Ticklish spots tend to cluster where nerve endings are especially dense and close to the surface, the ribs, the underarms, the soles of the feet. So more sensitive skin in those areas can mean a stronger reaction almost by default. But density of nerves alone doesn't explain everything. Two people can have similar skin and still respond completely differently to the exact same touch. The rest of the answer circles back to everything you just learned. Ticklishness isn't a fixed setting. It's a response built on prediction, trust, and context, all running through that same self-monitoring system. Someone who's anxious or on edge is often more ticklish, not less. Their nervous system is primed to react to unexpected touch in the first place. Someone who's relaxed and fully trusts the person touching them often reacts less, even to the same spot. Even your relationship with the person matters more than the location on your body. A ticklish reaction from a sibling can feel completely different from the same touch by a stranger, even though nothing about your skin has changed in between. So ticklishness was never really a fixed map of your body. It's closer to a live reading of your nervous system's best guess about who's touching you, and whether that's something to laugh about or brace against. Some people just run that calculation a little more sensitively than others, which loops back to the finger on your arm. Try it again if you want. It still won't work. Not because something's missing, but because your brain already knows exactly whose hand that is.